So in this example, I'm just going to go over how we actually do synthetic, whoa, give me a pen, come on. How we actually do synthetic division. And we went over this in class, I'll just speed through it right now. You take the root of the divisor, and the root there is -2, and you take the coefficients of the dividend. Dividend's up top, remember? Take those coefficients and put them here. 2, 9, 13, and 2. And before we get any farther, I just want to remind you, if you are ever faced with a polynomial that has a term missing, like what I just did here, goes straight from 9x squared to 2, you have to remember that there is still an x there. It's just a plus 0x. So you have to put that 0 in here as a placeholder. Okay, so don't forget your zeros if you've got a missing term. But in this case, we don't, so we're just going to go straight ahead. I bring the 2 down, I multiply it by -2, and that makes -4. Then I add down, and that gives me 5. And you repeat that pattern over and over again. So 5 times -2, -10. 13 plus -10 is 3, times -2, -6. And add them up, you get -4. So here's how we decipher these numbers here. These, let me get a better color here. These colors, these numbers right here are the coefficients of your quotient. So that means your quotient is 2x squared plus 5x plus 3. And how do I know it starts at 2x squared, not 2x cubed or 2x to the 4th? Well, you just remember, you take a look at the degree of the polynomial on top that you started with. That always just gets knocked down by 1. Because the power functions of the two things, if you look at them this way, this is a 2x cubed function divided by x. So we shouldn't be surprised that we get a 2x squared. Okay, so that's how you keep track of the coefficients. Now, last number over here, this is the special one, -4. That's your remainder. And a lot of people actually prefer using synthetic division for all their remainder needs, and they just forget about the remainder theorem completely, which I think is a bit of a mistake. There is value in the remainder theorem. That being said, it is awfully convenient to just use synthetic division.